Hey, my name's Will, N5OLA. This is the Heathkit HW-101. I love this rig, but it's a little bit complicated to align. So I thought for my friends out there who are restoring these babies, I would provide some pointers on how to get through the receiver and transmitter alignment process. It's a little bit of a journey, but it's not difficult, and I'm going to try to be as detailed as I can be. I'm going to be using an RF probe in this alignment. If you don't have one, you can still do the alignment, follow the instructions in the manual. However, I'm going to be deviating a little bit from the manual because you get more accurate results with an RF probe. And it's a good investment if you can get one. So let's begin. There are 7 pages in the manual devoted to the alignment process. It looks like a lot. It's really not that bad. If you don't have an alignment tool like this, there are some for sale on eBay. You must have an alignment tool. Next, a basic digital multimeter. I'm going to be using also this Heathkit IM16 voltmeter. Ignore the oscilloscope on top. You don't need a scope, but it's very helpful if you have an old school voltmeter that has a 1/4 inch input like this one on the lower right corner. You need that input to use an RF probe. This is an RF probe that I picked up on eBay. The RF probe is going to be used in 2 steps of this process. Is it absolutely required? Well, if you want to do a good job, yes, but you can get by without it. Set your radio up according to these parameters. We'll start out by adjusting the S meter. Super easy. So we're set up in PTT and ALC. Now I'm just going to adjust this zero adjust control. Just want to make sure that needle is on 0. That's all you got to do. We're going to start out the receiver alignment by just making sure that all the Heterodyne oscillator coils are within an acceptable range. We're going to fine tune them later. These are the Heterodyne oscillator coils, as well as that 14 and that 3.5 and that 28.5. Okay, for this step, I'm going to have my digital multimeter set for DC voltage. I like to put the black lead right there on the RF cage. The red lead is going to need to go at the test point. You see that TP right there on the board? It's kind of obscured by this pin. You probably have a hole here. I put a copper pin there just so I would have something to grab onto. You insert your red lead into the hole, and then you need to apply pressure because just sticking it in the hole is not going to establish a contact. So put it in there and press down or press up until you see something on the meter. Our goal here is to put the Heterodyne oscillator voltages somewhere in the range of -0.5 to -2. That's right here in the manual. Okay, that's what my 80 meters looks like. So I'm going to adjust this coil until I've got this down to about -2. And I can see that it's very sensitive. There's nothing magical about the -2 to -0.5, except that it's going to put it in a range where the band is alive and we can tweak it down the road. If it's something like -6, you may not even hear anything on that band. So you want to get it within that range. By the way, fun fact, you don't have to check these Heterodyne oscillator coils in order. You can just do these 3 bands first, get them within that range, and then flip the rig around and do the other side. So we started with the 3.5. Now I'm going to do the 14, the 20 meter band. And that's the reading I've got. So I'm just going to adjust that coil and get it down to that acceptable range. Again, that range is just our starting point. later on we're going to revisit the heterodyne oscillator voltages. Okay, now I'm going to go down and do 28.5, and that's within range. Now I've flipped the rig around so that I can check the heterodyne oscillator voltages on these bands. By the way, you can take your red test lead and you've got a hole here. I don't have that hole because I've got a pin there, but you'll find a hole here for that test point. Just stick the red lead into that hole, press on it so that it's getting contact. That way you don't have to be trying to hold it on this side while you work on this side. Okay, so let's go to 21 megahertz, and I am within range, so I don't have to adjust it. Now we go to 7 megahertz, and so I'm going to just adjust that coil till I get, it's very sensitive there. There, that's good enough. What happens if you come to one of these and you're adjusting and adjusting and there's no change here? That likely means that one of these, that the corresponding crystal for that band has gone bad and you've got problems. You're going to have to get a new crystal. There are other things that could be wrong, but that, in my experience, is what usually causes the band to be dead when all the other bands are alive. And when I say dead band, I mean a band that has no heterodyne oscillator voltage. That's what a dead band looks like. This is actually negative 0.155 volts, because right now it's in MV, but it's actually negative 0.155 volts. So if you see that, you've got no voltage on that band. Now watch what happens. I'm going to turn that back in, and I'm going to get a reading. Aha, now the band is alive. But as I keep turning, it goes away again. And if I keep on turning, now that slug is way in there. I've got voltage again. So you want to be sure that the slug is in the second deeper position of the tuning coil. You don't want it like close to the top. You want it in that second lower position. And by the way, I'm going to turn the volume up. And you can actually hear the band come alive when it's got voltage. Okay, I'm going to assume now that you've gone through all the bands and you've got those heterodyne oscillator voltages within range. And now we're going to adjust 3 transformers, T201, T103, and T102. Now let's fire up the calibrator. There are proper calibrator signals and then there are harmonics. Right now what we have is a harmonic. I know that because the pitch doesn't change when I change bands. Now that's the true calibrator signal, and you'll know it because it disappears or changes pitch when we go to a different band. All right. There's T201. There's T102 and T103. So I'm going to insert my alignment tool. And as I turn, I am going to see a change in the meter. And I'm just going for maximum reading. Now I'm going to go to T102, and this one has 2 positions. There's a top slug here, and then if I go down below, I can feel there's another one. So let's do the top first. Okay, and now I'm going to lower it in 1 step and keep adjusting. Again, we're just looking for maximum reading. There we go. And finally, T103. Oh, wow. If you get to the end of the meter like this, you can always back off a little. And then just keep tuning. Now we come to the dreaded alignment of the VFO, and I gotta admit, the first time I aligned a VFO by these instructions, I had no idea what they were trying to say here. I don't get this. It talks about walking the signal up and down and using a general coverage receiver. Man, let me show you the way I do it. Now, the best, most accurate way to do it is with a frequency counter. If you don't have one of these, then I'm going to show you the next best way. First of all, make sure that your VFO is such that you hit a hard spot right about there, okay? Somewhere on the word stop or in this little black space right there, make sure that that's as far as your VFO will move. If you're able to keep turning it into the black, then you're going to have to go back here and just with your finger move the dial mechanism until you're right about there. Now make sure this tuning capacitor has the little notch here pointed at the calibrator crystal. That notch pointed right there. Here's the thing about calibrator crystals. They're not 100% accurate. So again, without a frequency counter, it's going to be close, but it won't be exact. So let's go back to calibrate. Now, if I turn it this way, I get a loud calibrator signal, and then it comes down into a trough. And if I keep turning it, I start hearing kind of a shadowy echo of that signal. You want to get right between the two of them in the trough. Okay, and that's where 0 should be. All right, and we're at 0. So if I tune up to, let's say, 200, is that line going to, is that going to still fall in that calibrator trough? It's pretty close, but you know, we're just a little bit off. We want to be right on the 200 right here. Why is it not lining up? Well, because we have these things called trimmer screws. There's one here and one here. What these trimmer screws do, essentially, is it shrinks or expands the frequency spectrum of the VFO. I don't know if that makes any sense. What we want to do is adjust those screws in a way that will put us on the mark here as well as the 0 mark. So now I'm going up to the 400 end of the band, and look what happens. There's my little trough. But look where my dial is. I'm almost 5 kilohertz off. And so the purpose of the tuning screws is to shrink the band just a hair so that when I'm at 400, according to the calibrator, right on the dot, I'm also at 0 right on the dot, according to the calibrator. And so begins the largely hit or miss approach to adjusting the trimmer screws and then checking to see if you've got it on the 2 points from 400 to 0. Man, what a pain. It's so much easier if you've got a frequency counter. But anyway, I'm going to set my dial right at 400. The calibrator's on. And now with my tiny screwdriver, I'm going to fish around until I can feel the screw in there. Not easy. Where is that thing? Okay, I've got my screwdriver locked in there. And now, when I turn it, okay, so I'm right in that notch. Now let's see what it sounds like at 0. Okay, so it's not exact. I mean, you can see like there's just it's on this side of the line, but you know what? Damn it, that's close enough. If you are not getting the same results, you have to keep going back to the trimmer screws, trim one or the other, check it at both points, 0 and 400. And you got to just keep going back and forth until they line up. And you'll see when you're adjusting the trimmer screws if you're going in the right direction or not. But it's very, very intuitive. And again, you can save yourself a lot of headaches if you've got a frequency counter. Okay, let's see where we're at. Step 1 was adjusting the Heterodyne oscillator voltages, getting them within range. Step 2, adjusting the 3 transformers. Step 3, the VFO alignment. And now we're on step 4, which is the fun part. This is the part that makes any HW-101 with low output suddenly come alive. So if you've got a rig that's putting out like, I don't know, 20, 30 watts, and you're like, this is not right. This is the step that's probably going to fix that. The HW-101 has 8 band settings. We are going to adjust only 5 of them. Got the rig back on its side. Got it set for 200. We're on 80 meters. It's very important to do these bands in order. So we start with 80 meters. We get the calibrator on. Turn the volume down so we don't go deaf. And then, all right, this is a really strong signal. So I'm going to back it down just a little so that when I start tuning, the needle doesn't go out of range. So we're going to be adjusting the driver grid and the driver plate. And we're in 80 meters, so we're going to adjust only the 80 meter tuning coils. Okay, I'm going to be turning the driver grid tuning coil to get a maximum reading. Oh, really important. Oh, how did I forget this? The driver preselector must be in the 12 o'clock position. So make sure it's right there. Super important. Okay, now I'm going to adjust this for a maximum reading. Okay. Now I'm going to adjust the driver plate for a maximum reading. Uh-oh. Okay, if this happens, you turn it and you get that clicking sound, that means your alignment tool is shot, as mine is. I'm going to flip it around. That should do the trick. Let's find the hole. There it is. All right. Looking for a maximum reading right there. Next, we go to 29 megahertz. So we just tested 80 meters. Now we're going to go up to 29 megahertz. And now we move the driver preselector. If that line is at 3 o'clock, it's going to be one line before 3 o'clock. All right. I've got my alignment tool in the 29 megahertz tuning coil, and let's get a maximum reading. Okay. Now driver plate. Doesn't matter which order you do these in, by the way. Okay. And then if you want, you can go back and just double check the first tune, make sure you're still getting the maximum reading. Oh, it just changed. How interesting. Okay, that changed. So let's check that one again. You can go back and forth until you're absolutely sure you're getting the maximum reading. Now we're going to go to 21 megahertz, 3 clicks, 1, 2, 3. And the driver preselector is going to move up 1 notch right there. Okay, let's start with the driver grid, looking for maximum reading. Driver plate. Let's go back and check the driver grid once again. Okay, now we're going to go to 20 meters, 14 megahertz. And the driver preselector goes to 12 o'clock, right where it was when we had it on 80 meters. Adjust the driver grid. Driver plate. Right there. Okay, now 40 meters. And the driver preselector stays right where it is at 12 o'clock. Let's tune around and get the best calibrator tone. Okay, now I'm going to adjust the driver grid. Again, it's 7 megahertz, driver grid, maximum reading. And now the driver plate. Okay, one more time, check that driver grid just to be sure. Okay, switch off the calibrator. And guess what? That's the end of the receiver alignment. All right, step 1 in the transmitter alignment is adjusting the bias. Set the rig up according to these parameters. Be sure that the mic CW level is all the way counterclockwise. You're going to need a mic for this step, and set the meter to plate. If for some reason you don't have a mic, you can always trigger the mic by grounding the switch pin like that, or with a wire. Okay, the bias is here. I'm going to key the mic, and I want to get the needle right in line with that little triangle. So I'm going to turn the bias control until I've got it right on the S3 or the triangle. And by the way, it's a good idea to check the bias now and then. Sometimes it slips out of alignment, especially if you use a different power supply. So, and you can adjust that without having to take the cabinet off. You'll have access to these controls through the cabinet. Next, we're going to adjust transformer T1 right here on the modulator board. Using the same setup that we had for bias, we're going to put it in tune and raise the level until we've got about S3. Okay, should be in relative power mode, obviously. If at this point you realize that you have no RF output, then stop the alignment, go back to the manual, hit the troubleshooting pages, and try to track down the RF problem. Okay, let's put it in tune. And we're going to adjust transformer T1 for maximum output. Next is neutralization of the finals. If you do not have an RF probe with a voltmeter that will work with an RF probe, you're going to have to follow the steps in the manual. What I'm going to do is show the use of an RF probe in neutralizing the finals. And to do that, I'm going to rely on these instructions from the service bulletins. These are on my website, n50la.com, and they're probably linked on this YouTube video. First of all, we need to remove the back panel and the top of the RF cage. By the way, I'm going to point out on my radio, I added a CW side tone volume control. The CW is kind of loud on the HW-101. This gives you a way to bring that volume all the way down to nothing. It's kind of a cool mod. Look it up online. I'm going to remove this final tube. Okay. And now I'm going to disconnect this red wire down here. Apply the soldering iron here and have a pair of needle nose pliers. And once the connection there is hot, pull it out. Put a piece of electrical tape on that exposed wire. Don't forget to do that. That's 800 odd volts. You don't want to touch it. And now I'm going to replace the tube and reconnect. Now we need to disconnect the screen voltage from the finals. And screen voltage is that 100 ohm resistor right there. I'm just going to heat it up, slide it off of this exposed wire. In most cases it will slide right off. Sometimes an intrepid builder will wrap that resistor around that bare wire and you're going to have to somehow get it off. But you want to have it so it's kind of hanging in space like that. Don't want it touching anything. Remember the RF probe? Well, mine died. I think I blew a diode. So I rigged up this wonky little homebrew device. Don't worry about what it looks like. Just remember that your RF probe will have the probe and it will have a ground connection. And the ground connection goes to chassis. And the probe, you can either insert it into the antenna jack, but that's awkward because it's going to slide out. I like to just use a jumper clip and jumper it from here to the center antenna input there. Okay, let's talk about what we're doing and why we do it. We're going to neutralize the finals. Anytime you pop in a new set of final tubes, you have to neutralize them. There's a lot of technical reasons for that. Basically, you want to prevent the tubes from oscillating. And to do that, we use the RF probe to sniff out any stray RF voltage. So basically, with the output level set at 0, there should be as close to 0 voltage as possible picked up by the RF probe. And we're going to see that on the meter. Okay, let's power on. Band switch should be on 28.5. And then adjust the pre-selector. Adjust it for the loudest signal. Put the mic CW level on high. Set it for tune. And look at that. Okay, let's get it. Let's try to get the maximum. See that screw hiding behind the pulley on the RF cage? That is the neutralizing capacitor. What I'm going to do is put it in tune, and I'm going to turn this neutralizing capacitor until I bring that RF output as low as possible on the meter. Okay, I'm going to start turning, and there we go. It won't go all the way to 0, although it should get damn close. And there we are. Finals are neutralized. Switch off the rig and unplug the RF probe. And now I'm going to resolder that resistor that we removed earlier and also the heavy red wire going to the finals. And at this point you can put the top of the RF cage back on and the back panel. Next, we're going to null the carrier, and that involves this control and this capacitor. We'll adjust this one first to get it as low as possible, and then fine tune it with the tuning capacitor there. Also need to reconnect the mic. I'm going to reconnect the RF probe just like before, except this time I've got the antenna connected as well. And connect it there. And there. RF probe is here. She's ugly, but she gets the job done. Now the radio goes on. Now I've got the mic CW level all the way counterclockwise. I'm going to set it to 3.5 megahertz and adjust the pre-selector for the loudest volume. So I'm going to key the mic and then tune the final for the highest reading on the meter. Now I will say it's a lot easier to do this if you have a desk mic. I'm going to have to actually do this like so. Very sophisticated, I know. Now when I key the mic, that is carrier oscillation, and we want to get rid of it. I have one of these Heathkit nut starters, which fits perfectly on that control. If you don't have one, a small screwdriver will do just as well. So I am going to key the mic and very gently remove as much carrier as we can. Looks like that's about all I can do. Let's try it again. Okay, well, we're going to introduce some troubleshooting into this video. Going down a little bit of a side road, but this null control is shot. They don't hold up very well over the decades, and they're known to fail. So I'm going to just assume it's dead, and I'm going to replace it with this 20-turn potentiometer. It's also 200 ohms. It's a more modern version and a lot more accurate. These are the 3 pins that connect to the PC board. What I'm going to do is I'm going to heat them up, and I'm going to pull all 3 pins out and clear the 3 holes there, and I'm going to leave that control in place. Mount this 20-turn pot on top of the board. Okay, there it is, right there. This one, by the way, is vestigial. It's just there to avoid leaving a big gaping hole. Okay, here we go, keying the mic. And I'm going to turn that till I bring that needle as far down as it'll go. And now I'm going to adjust the tuning capacitor as well. And there we are. Carrier nulled. Now the Heterodyne oscillator coils. Remember that? We started with it, now we're going to end with it. This is the 80-meter Heterodyne oscillator coil, and you'll note something. It's got a short side and a long side. If I turn it one way, that's the short side. I'm going to turn it back, and now watch it kind of ease down. Okay, that's the side you want to be on. So you want to adjust the coil for the highest reading, and then you're going to reach a point where it doesn't go any further. And once you reach that point, back up again, find that point, and stop. If you go too far, you go off the cliff. Boom. As you'll remember, we've got 14 megahertz, 3.5 megahertz, and 28.5 on the top side of the board. So I'm just going to go ahead and adjust all of those first and then flip the rig on its side. So all the Heterodyne oscillator coils are tuned. Now what I want to do is just go through band by band and make sure I've got full output on every band. This is 80 meters, and look at that. It's got well over 100 watts, something like 110. I'm going to do that for every band. If you come to a band and you don't have full output, so look at this. I'm on 7 megahertz. I've got about 80 watts, but what I need to do is turn the loading coil as well. And that brings it way up, way, way, way up. I'm going to pull it down to 100 watts right there. Keep in mind, you should have around 100 watts on these first 4 settings, and then about 80 watts on the next 4. And that's within the rig specifications. You just don't get as much out on those higher bands. Okay, we're going to align the crystal calibrator now. And if you follow the manual, it notes that you should have an external general coverage receiver, one that's capable of pulling in WWV. WWV runs on 5 megahertz, 10, 15, 2.5. It's all over the place. I'm going to tune into 5. WWV has a 0 beat. Remember how we were talking about that with the VFO? Listen to this. See, we're in a trough right there. Now, the manual says connect a random wire from the transceiver to the receiver and 0 beat against WWV. The problem is I don't know how to run a random wire into the antenna input of this receiver while there's an antenna in the socket. Now, I could open this up and I could tap into the center pin of the antenna. What I'm going to do instead is just, I'm going to 0 beat this, and that is the 0 beat. And now I'm going to disconnect the antenna and run this random wire from the antenna input on this one to the antenna input on the HW-101. Okay, I've got that random wire going from there to there, and watch what happens when I turn on the calibrator. I can hear it through the radio. So what I'm going to do now is just adjust the calibrator pot on the HW-101, and I'm going to listen on the receiver and hear it 0 beat. See if you can hear it. It's not very loud. And by the way, don't worry about the fact that this is 1 kilohertz off. What we were doing is synchronizing to the 0 beat of WWV. So I now pronounce the calibrator calibrated. And by the way, if you don't have the means to do that calibration, just make sure this notch is in the middle, pointed toward the crystal. That's how the manual specifies that it should be positioned. And guess what? After calibrating it, it's only a hair's breadth off of center now anyway. So if you have that notch centered, you're probably going to be okay. Final step, the VFO shifter adjustment, super easy. Here's what we're going to do. We're in 80 meters, set it to USB 200, calibrate. And once we flip this over, we're going to 0 beat it. Right there. Now, don't touch anything. Just switch over to LSB. And then adjust this for a 0 beat. Now when you switch back and forth between LSB and USB, you should be 0 beating in both places. And that's the way it should be. Ah yes, one last thing, dial calibration. After doing all this, your dial may have gotten out of adjustment. All you do is turn on your calibrator, go to a 100 increment mark on the dial, See how it's not on the line? All you got to do is hold in this button, turn it this way, and now there you are. And that's a wrap. Thank you for joining me. I know that some of these steps deviated a bit from the manual. If you want to adjust the VFO and you don't have a frequency counter, just follow the steps in the manual. Same for the carrier null, same for the final neutralization. I highly recommend picking up one of these old school voltmeters or a vacuum tube voltmeter. You will also need a digital voltmeter, of course. And if by any chance you can spare $100 and pick up one of these portable frequency counters, they are wonderful. So much easier than using the steps in the manual. I hope this has been instructive. Thank you so much for watching. And 73, just a postscript. These are 200 ohm, 20 turn potentiometers. You can get them on eBay for about $1 a piece in quantities of 10. They're cheap. And if you have the old carrier null pot, you're probably going to need one of these sooner or later.